Okay, we are going to do the derivatives, which means you differentiate of logarithmic function. Okay. How does a logarithmic function look like graphically? So you ask yourself a question like this: what is a log function? Now let's use y equals to lg or ln. All right, base 10 or base e. Okay, I write ln. Okay, let's try to use our recollection. When x is 1, what is the value of ln 1? Without calculator first, what do you think? Ln 1 is how much? Okay, that's very sad. Ln 1 is? No, ln 1 is 0. Okay, so ln 1 is actually 0. Now, what about ln 0? Error, Okay, undefined. What about ln negative? You get undefined again. What happens if you ln a decimal? 0.5. Let's ln a decimal. You get a negative value. How does a ln graph looks like if you were to so-called plot it? Now, these two terms here means that x cannot be what? X cannot be 0. X cannot be negative. So all this region I don't want. Where x is 1, y is 0, right? So I need this point here. Okay, I put a dot here. How does the curve look like? When x is a decimal, like 0.5, 0.4, 0.3, the y value will be a negative value. So on this part here, all the y's are negative. So if you don't want to cut over here, there's only one way of drawing. So this is the logarithmic curve. What happens when I differentiate? I find the slope at every single point. I find the slope at every single x value. I find the slope at every single x value. How will the dy dx look like? It will look like this. This part here is not possible because x cannot be negative, right? So I will only have this part here. So what type of function does this look like? Okay, so this is 1 over x. All right, so when you differentiate ln x or log x, you'll get dy dx is 1 over x. So you'll get dy dx here as 1 over x. When I differentiate ln x, what do you think I will get? One more time. When I differentiate ln x, what will I get? I will get 1 over x. Please memorize this. For differentiating a ln function, actually the answer is just this. But I will strongly suggest that you use this acronym for the steps. So DRF, you differentiate the bracket first, you remove the ln, and then you flip the fraction. Not very difficult, right? Yes, so let's look at this. What fraction is ax plus b if I were to write a fraction? Ax plus b, the fraction is over 1. Okay, let's do the step. You'll become very, very simple to do logarithmic differentiation once you have the step. Okay, first step, differentiate the bracket. A, right? Remove the ln. Flip the fraction.
Oh, that's what you mean.
That's why I get this. Okay, so you must be thinking, from here to here, I can do it easily. Why should I have DRF? Later when you do this, you have problem. If you don't do DRF for complicated questions. Okay, let's try the simple ones first. How do I differentiate this? You realize it's actually question 2b. That means it's a simple question. So it is not like bring down the power minus 1, differentiate inside. No, it's a logarithmic function. So how do I simplify this logarithmic function? No. How do I simplify this logarithmic function?
Or 3 ln.
Yeah, the power for logarithmic function can bring down. So do you realize you forgot some stuff about logarithms already? Okay, which is why the TYS for this will be coming up soon. Okay, so that is how you simplify the logarithmic function. The constants, you do not need to differentiate. So you just need to focus on this part. Then you multiply by 3. That will be how you differentiate. Okay, let's try. So the 3, I leave it here first. Differentiate the brackets. Remove the ln. Flip the fraction. So if you are able to do this, okay, you can do it in one step. If you can't, you just do it this way first. Differentiate the bracket, remove the ln, flip the fraction. But if you can do it straight away like this for simple questions, okay, I will just write as a single fraction straight away. Final answer? Negative 6 over 7 minus 2x. Or positive 6 over 2x minus 7. Up to you. You can write positive 6 over 2x minus 7. Okay, 2C, let's do again. First step, what do I write? Come together. What do I write? DRF. Yeah, so what do I write first?
2x.
Yeah, 2x. Remove the ln. Flip the fraction.
X12 plus 1.
Yeah. And we are done.
Oh, wow.
Yeah. So why is it so easy? Because the ln disappear, that is a life-saving thing. The ln disappear, we are no longer worried about loss of logarithms. You don't have to worry. Now I want to differentiate this. Okay, DRF. D. Other than Jeline, the rest, do you know how to differentiate? Answer is? You must say out loud so that you can remember better. R. F. So now I buy in my trademark already, DRF. Again, I come up with this morning only. All right. Everything I do is I only come up this morning only. Very nice to your batch already. Okay. What comes to your mind before doing this? Yes, thank you. Product rule. So differentiate the first term, put down the second term, plus differentiate the second term, put down the first term, product rule. And the answer is ln x plus 1. Okay, can you use the law of logarithms to split it into ln 4x plus 3 minus ln 2 minus x? Yes, we can. Okay, I'm going to do this question in 2 parts. One part using DRF, one part using law of logarithms. Let's try, see how different the answers are. Okay, we will use this DRF. Differentiate the bracket. No. Yeah, correct, sorry. Differentiate the top first. I'm used to differentiate the top first. Differentiate the top first. 4. Put down the bottom. Minus. Differentiate the bottom. Put down the top. I have my own sequencing. So if you say anything that is not in my sequence, my brain will hang for a while. Will stall for a while. So you must follow. Differentiate the first one. Okay, so D, R, flip, F. Does it help, DRF? Let's simplify the numerator. I'm going to cheat a bit. I try to look for it. If you simplify the numerator, it will be 11. Can you see that these two can cancel off one of the 2 minus x? So left 2 minus x at the bottom. This one no more already. I cancel one of them. And this one is at the denominator also. And that's the answer. Now, what happens if I use the law of logarithm first? No, it's the same answer. Just I want you to feel the process of either DRF first or law of logarithm first. Okay, let's use the law of logarithm. What's the answer here? And straight away you must come. Very simple. Then this one? Plus 1 over 2 minus x. Common denominator. Okay, why common denominator? Because I try to see whether these two can become the same. Times 2 minus x times 2 minus x multiplied by 4x plus 3 multiplied by 4x plus 3. So the common denominator will be 2 minus x, E max now, 4x plus 3. So let's expand. We have 8 minus 4x plus 4x plus 3. You will get exactly the same answer. Okay, can I have the video to stop, please?